Hello everyone, welcome to easyedu, and today we are going to solve this numerical. The numerical is what is the kinetic energy of a 5 kilogram solid ball whose diameter is 15 meter if it rolls across a level surface with a speed of 2 meter per second. So in the given data we have mass of the ball, which is equal to 5 kilogram. Diameter of the ball is given as 15 meter, and dividing this diameter by 2 we will get radius is equal to 7.5 meter, where the linear speed is given as 2 meter per second. So for determining kinetic energy, as there are two types of motions in this ball, one motion is along this straight line, which is translational motion, while the second type of motion is rotational motion, because this ball is rotating around its center of axis. So it has two types of kinetic energy. One is translational kinetic energy, which is simply we know 1/2 mv square, and the second is the rotational kinetic energy, which is 1/2 I omega square. So we will determine both of these, and then we will add both of these kinetic energies to get the total kinetic energy. So the translational kinetic energy we know is equal to 1/2 mv square. So mass and velocity both are given. Substituting the values for mass and velocity and solving, we will get 10 kilogram meter square per second square. Here this is 1/2, this is 5, and taking square on this 2 it will become 4, and then dividing that 4 by this 2 it will become 2 again, and multiplying that 2 with 5 we will get 10. So the translation kinetic energy is equal to 10 kilogram meter square per second square, which is joules. So the translation kinetic energy is 10 joules. This is part 1 of this numerical. Now solving the second part, which is 1/2 I omega square, or the rotational kinetic energy. The rotational kinetic energy is equal to 1/2 I omega square, where I is the moment of inertia and omega is the angular velocity. So we will determine the angular velocity of this ball and the moment of inertia of this ball. First, let's derive the value for rotational velocity. We know that translational velocity and rotational velocity are related to one another by this equation: v is equal to r omega. We need the value of omega, which is rotational velocity. So we will have omega is equal to v divided by r, where v is the translational velocity and r is the radius. The translational velocity value is given as 2 meter per second, and the radius is also given as we have determined from the diameter. The radius is 7.5 meter. So substituting the values, we will get 2 divided by 7.5. Dividing this 2 by 7.5, we will get 0.267 radian per second, and this is the rotational velocity of this ball. Now we need to calculate the moment of inertia of this solid ball, and the moment of inertia for different shapes object is different, but right now we are dealing with a sphere, and the moment of inertia for a spherical shape object is 2 divided by 5 mr square, where m is mass and r is the radius. 2 by 5 is a constant value. So substituting the values for mass and radius, we will get 2 divided by 5, multiply by 5, and then multiply by 7.5 meter and taking whole square. This 5 will cancel out with this 5, and taking square on 7.5 we will get 56.25, and kilogram is here, and this meter will become meter square. So we have 2 multiplied by 56.25. Multiplying both of these terms, we will get 112.5 kilogram meter square, and this is the value for moment of inertia. Now we have the value for rotational velocity or angular velocity, and we also have value for moment of inertia. Substituting these values in this part of this equation, which is the rotational kinetic energy, or we can say angular kinetic energy, is equal to 1 over 2 112.5 kilogram meter square is the value of moment of inertia which we have determined, and 0.267 radian per second whole square is the value for this angular velocity omega. Substituting this value and this value in this equation, we will get 1 over 2 into 112.5 kilogram meter square into 0.267 radian per second whole square. Now solving this term, we will get 56.25 kilogram meter square by dividing 112.5 by 2. So and taking square of 0.267 radian per second, we will get 0.071 radian square per second square. Now multiplying these two terms, we will get 4.01 joules, and this is the rotational kinetic energy. Now we know that translational kinetic energy is equal to 10 joules, and the rotational kinetic energy is 4.01 joules, and the total kinetic energy is equal to the sum of the translational kinetic energy and rotational kinetic energy. Substituting the values for kT and kr, we will get 10 joule plus 4.01 joules, which is equal to 14.01 joules, and the final kinetic energy, or we can say the total kinetic energy, is equal to 14.01. So this is the kinetic energy of this solid ball. That's it. Thank you for watching, and do not forget to subscribe easyedu.